For question 2, we have a cone and then we are going to cut the cone so that it forms a zeta. Imagine in figure A, the cone is a paper cup. You try to cut it along the edge of the paper VQ. And after cutting, VQ becomes this line. And the original base circumference indicated by the green line becomes the arc length of the zeta. Now we want to find the base radius, or you can say actually we want to find OQ. Because in a cone, for the base, the circle base, OQ is the radius, so OQ is the answer that we need. Now we know that this cone has the volume of 1500 pi cm cube. And actually, based on this information, we can already find the base radius. We know that for a cone, its volume is 1/3 pi r square h. And for r, for volume, we know is 1500 pi. For the r is the thing that I want, h is 20. Therefore, we just put back the values and form the equations. Let the base radius be RCM, because the volume of the cone is 1500 pi cm cube. So 1/3 pi r square times 20 will be 1500 pi. Now the unknown that we concern is r. And for the remaining parts, 1/3 times pi and 20, we can use division to move it to the right. After that, the left hand side will be r square, and then the right hand side will be 1500 pi divided by 1/3 pi divided by 20. And after simplification, we know that r square 225. And to get r, we also square root on both sides. Left hand side has r, right hand side is 15. So we know the base radius is 15 cm. And for B part, we want to find the curved surface area of the circular cone. So for a curved surface area in circular cone, the formula is pi times the base radius r times the slant height L, which actually is the VQ. But how can we find the VQ? We have the R, which is 15. But we don't know L, VQ. Actually, we can use the Pythagoras theorem by referring to the triangle VOQ. We now have VO 20 cm, OQ 15 cm. So By Pythagoras theorem, we know that VQ square equals to 20 square plus 15 square. Or you can just write down the length in their square root form. VQ equals to square root of 20 square plus 15 square, which will give you 25. You now know that L is 25, so the area, the curved surface area that we need is pi times 15 times 25, which will be 15 times 375 pi. You need to keep the answer in terms of pi as mentioned in the question. In part C, we finally refer to the angle theta in the zeta. We finally refer to figure B. And now let us put some information that we know in the previous parts. That is VQ equals to 25 cm and the curved surface area. Actually, the 375 pi cm square that we get in part B is the zeta area. And now we want to find theta, the angle of zeta. We make use of the zeta area formula. For the zeta area, its formula will be the area of the whole circle, pi r square, times the part of it, theta, over 360 degree. So it is part of the whole circle. If we cut, we can imagine that it is originally the whole circle and we cut 360 pieces out of it, and because the angles at center actually is 360 degree, and then we get theta pieces, so we times back the proportion of a zeta, theta over 360 degree. And now we know that because the curved surface area of the cone after cutting, it will be the zeta area. So the zeta area itself is 375 pi cm square, and we know that pi times the radius of a zeta. Okay, pay attention to the r. This time the r is not referred to base radius OQ in figure A. It has been cut. The base in figure A disappear already. Now we just cover the figure A. We just notice figure B. In figure B, the radius is VQ, so it's 25 cm. It has changed. So R is 25. Pi times 25 square times theta over 360 degree will be 375 pi. Now the unknown that we want to find is theta. We do it part by part. First, using division to remove the pi times 25 square. And when you press the calculator to simplify the right hand side, pay attention that a bracket should be put in the denominator. And which will give you 0.6 on the right. And then for the left hand side, we do the last step using multiplication to move the 360 to the right. So theta will be 0.6 times 360 degree, which will give you 216 degree. So we now know the angle theta of the setup.